Hello, this is Dylan on January 24th doing check-in number 3. Number 1, time spent studying, about 6 hours, about 2 hours yesterday on homework, and 4 hours today watching the videos and doing homework. The videos that I watched was chapter 12, N1, and E1, I believe. Let me look. Yeah, I started N2 as well, but didn't finish. N1 basically just reviewed how chapter 11 was about, kind of reviewing kinematics. But in chapter 12, we're going to be using the kinematic equations and deriving them. Or in other words, using two different kinematic equations, combining them in order to get acceleration and find that with relation to the givens, which are usually mass or time or a weight, and or velocity. And that was basically N1. And then it went into more detail about how we're going to eventually use more components such as momentum in orbital motion, those sort of things. And to be honest, this is the first time I've heard of theta prime, r prime, r double prime, theta double prime. So that's taking me a minute to understand. Then chapter 12, E1 basically just went over how to do that, how to derive two kinematic equations in order to find acceleration. And from there, then you can find the maximum height and the time that it takes to get there with the limited information that we have. So pretty cool. Next on the checklist, check in. Homework problems completed. I completed number 1 and number 2. And basically we were able to use the equation force equals ma, but then we turn acceleration into, I forget the, I can't think of the form, but basically a equals dv dt, the derivative of velocity with respect to time. You plug that in, and that's one of your kinematic equations. The other one, I can't remember exactly what it was for number 1 or number 2. If I go out of this, we'll end the video. But basically you have your second kinematic equation. You combine those, separate your components with respect to velocity and variables with respect to time on either side. You integrate that with the times that it gives you, and you're able to find the unknown t. From there, you can use that t to find the distance. You just, instead of taking acceleration, you're deriving using dv dx with respect to distance instead of time, and then you just derive it with the components that it gives you. And then, let's see, for number 2, it was very similar with the car and the tension. And that was gone over in the first video of how you would take the x and y components and turn that into a different kinematics equation that you could use. And I guess I'm not necessarily supposed to explain the solutions. Other efforts, I'm changing my work schedule so that I can meet with my group more, and also study groups more on campus. And summarizing what I learned is, the gist of it is taking your kinematic equations, putting them, rewriting certain components as derivatives, then you're using that derivative form to combine two equations, take the integral, and find your solution. So you're basically deriving your kinematic equations from chapter 11 and using those. And yeah, that is it.